study of resonance in electric circuit. So in this experiment, we are going to study resonance phenomenon, which is a strong increase in amplitude of oscillation in case of coincidence of the frequency of external force with the frequency of natural oscillation of some oscillating system. And in this case, we are considering oscillations in electric circuit which contains capacitor and inductor. If these two elements present, then the system allow self-oscillations, and in case of external voltage attached to it, we can see the resonance phenomenon in this system. First of all, we need to connect wires according to the scheme. The scheme is here. So this is the scheme. So we can see that here is the generator of electric signal, and the wire from generator goes to capacitor. So I connect one wire here. Then from capacitor, wire goes to inductor. Connect this capacitor to the inductor. Here. Well, from inductor, the wire goes to resistor. This inductor, this is resistor R1, and from resistor R1 it is connected to resistor 2, which is permanent resistor, and this is necessary to be able to change total resistance of system, having a part resistance unchanged for measuring of currents, for example. And from resistor R2 the wire goes back to generator. So I connect the generator with the resistor R2. Now the wires are connected, and I can turn on the generator. I need to wait some time until the generator is warming up, and I can turn on the voltage meter now. So here we are going to measure the dependence of voltage on different parts of system on frequency. This generator allows us to change frequency, and the frequency is shown here, and we can change it without changing of the amplitude of the voltage. So voltage is stabilized and frequency can be changed. This is a very old device. It was made in 1968, but it is stable, it's still working, and due to its old age, it requires some time for warming up. Now we can start measuring. For this reason we use this precise voltage meter. It has a lot of ranges of measurements. The maximum range is 300 volts and the minimal range is 1 millivolt. So at the moment the range is 10 volts, but we cannot see any signal on this range. So I decrease the total range, and this one is good for us. It is 100 millivolts, so we can measure voltage and the whole scale is now equal to 100 millivolts. So this chain is actually 100 millivolts, and these two, for example, 20, 30, 40, and so on millivolts. So now the voltage is 20 volts. I can record it here in the table, 20 millivolts. Then I change frequency, which is 1100, and the voltage now is 22. Then again I change frequency, and voltage become 26. So I continue this process longer, and the total measurements required for this experiment is 36 measurements. We'll not show you all the process, so let us pause the recording. Well, now we need to record the values of voltage on inductance. For this reason we change the wires inductance, and we use the same limit which we have used for capacitor, and let us start with 1000. 1000 we have 10 1 volt actually, because this 1 is now 1. So 1 volt for 1000, 1100 we have 1.1, 1200 1.3, and so on. Again we can stop. After we have collected all the data, we need to draw two graphs. First graph is the dependence of UR, voltage on resistance, on frequency. For this reason I use insert, and this is scatter type of diagram, and I'll take this one. Now from this graph one can see that the dependence of voltage on frequency has resonance behavior. It first increases, then decreases, and we can see that maximum of the curve lies at this value, which is 1800 Hz. So if we find the resonance frequency from the graph of UR, we can find it is 1800. At the second stage we should draw another graph. Let's move this one aside. And this just okay, I'll try to draw another graph. Maybe it will be, I will open the first one. So I need to select first column, and then I press Ctrl and select C and D, third and fourth columns. Interesting. Do it in opposite manner. So first I'll select, it's not easy using touchpad. Well, then I press Ctrl and select the first column. So the three columns are selected now, and again I use insert, scatter type of diagram, and this type. So this is a new diagram. It represents the behavior of voltages on capacitor and inductor on frequency. I will move it down. So we can see that again the behavior of voltage on frequency, the dependence of voltage of frequency has resonance manner, and compared to the resonance on resistor, these two resonances are asymmetrical. You can see that increasing part and decreasing part does not look similar, and the maximum of curve for UC is shifted towards smaller frequencies. So it appears at approximately 1600, this value. Maximum value for UL is shifted to larger frequencies, and it is probably at 2100 or 2000 exactly, somewhere here. And there is a point of crossing of two lines. At this point, the voltage on the capacitor coincide with the voltage on inductor, and in our case this point corresponds to 1900 Hz. So if we determine resonance frequency from these two graphs, we should say that the resonance frequency should be 1900, and it is close to the result obtained before from the graph of current on voltage on resistance, where it was 1800. So we can fill now the second table. Now, can fill this table. The value determined by maximum of UR is 1800. The value determined by coincidence of UL and UC is 1900. And it is easy to calculate average value. In this case, it is 1850. From this value, we can now calculate inductance. For this reason, we'll use the equation for omega, which equals to 1 divided by LC by square root of LC. So we can say that LC equals to 1 divided by omega squared, and then L equals to 1 divided by C omega squared. And omega can be found from knowledge of resonance frequency, which is 2 pi f. That's why L equals to 1 divided by 0.1 and 10 to the power minus 6 multiplied on 2, 3.14 multiplied on 185 and squared. So now we can calculate L and record the result in this cell. And that is completed exercise.